Hello, this is the lesson for Wednesday, August 16th, and our topic is going to be on the angle addition postulate. But before we begin, we're going to do some bell work, just reviewing previous lessons. And number one says T is the midpoint of segment PQ. P to T is 4x minus 6, and T to Q is 3x plus 4, and we want to know what are PT, TQ, and PQ. So first thing, of course, we should do is draw a picture of what is stated. So it says T is the midpoint of segment PQ. So that means P and Q are the endpoints. T is the midpoint. So we're going to mark those congruencies. And then it says P to T is 4x minus 6. T to Q is 3x plus 4. And we want to find the value of x first before we can answer the questions that are being asked here. Since T is the midpoint, that means that the distance from P to T is going to equal the distance from T to Q. So 4x minus 6 equals 3x plus 4. We want the variable to be on one side of the equal sign, so I'm going to get rid of the 3x. 4x minus 3x is just x. Bring down the minus 6 and the equals 4. Then we're going to get rid of the minus 6 by adding 6 to both sides. 4 plus 6 is 10. So now that we have x equals 10, we can find the lengths of each piece in this problem. So starting with P to T is 4x minus 6, so that would be 4 times 10 minus 6. 40 minus 6 is 34. Okay, then TQ, it should also equal 34, but I'm going to use the 3x plus 4, so that's 3 times 10 plus 4. This is a way of just verifying. Yep, 3 times 10 is 30, plus 4 is 34. So then to do the distance from P to Q, that would be P to T plus T to Q. So that is 34 plus 34, which is 68. So those are the three answers to the first bell work problem. P to T is 34, T to Q is 34, and P to Q is 68. Okay, so now I'm going to go to example number 2 in our bell work. It says T is the midpoint of segment PQ. P to T is 7x minus 24, and P to Q is 10x plus 40. What are PT, TQ, and PQ? So once again, we're going to draw a picture of what we're given. T is the midpoint of PQ, so that means P and Q are the endpoints, and T is the midpoint. So since it is the midpoint, that means the left side equals the right side. So and then P to T is 7x minus 24, but this time we are given P to Q is 10x plus 40. All right, so now we're going to solve this problem using an equation. Of course, the first thing we should recognize is that the left side equals the right side. So that means T to Q is also 7x minus 24. So I'm going to use the segment addition postulate here. So that means 7x minus 24 plus 7x minus 24 equals the whole thing, 10x plus 40. So now we'll combine like terms. 7x and 7x is 14x. 24 and negative 24, excuse me, and negative 24 is negative 48. Bring down the 10x plus 40. So I'll get the variable on the left side by subtracting 10x on both sides. So those cancel out. That gives me 4x minus 48 equals 40. All right, and then we will add 48 to both sides. So 4x equals 40 plus 48 is 88. Divide both sides by 4. 88 divided by 4 is 22. So now we need to find the answers to the questions, which are to find PT, TQ, and PQ. So starting with PT, PT is 7x minus 24, so that would be 7 times 22 minus 24. Definitely going to want to use a calculator on this one, which remember, calculators are almost always allowed. So we're going to go ahead and do that. So I'm using my calculator right now. I'm doing 7 times 22 and then minus 24. And so 7 times 22 minus 24 is 130. And of course, PT and TQ are exactly the same. So TQ would also be 130. And then I need to do PQ. It should be 260, but I'm going to go ahead and use the 10x plus 40 kind of to verify that I've really done this work correctly. So that's 10 times 22 plus 40. So again, I'm going to use my calculator. 10 times 22 plus 40 is 260. P to Q is indeed 260, 130 plus 130. All right, so we have now finished our bell work. So now the next thing we're going to do is we're going to move to angles. All right, so taking a look at angles. So we're going to go ahead and draw this picture right here. And I have an angle that looks kind of like this, a big angle. And then I'm going to draw some two smaller angles by drawing an extra ray in here. I'm going to put some letters on this. This is going to be point Q. This is going to be point T. This is going to be point R. And this is going to be point S. And I'm going to name this angle right here angle 1 and this angle angle 2. We often do name angles in a picture using a number. So angle 1 can also be named using 3 letters, 1 point on each side of the angles. So if I look at angle 1, it is created by 2 rays, ray TQ and ray TR. And those 2 rays, of course, share a common endpoint of point T. So we can name angle 1 using 3 letters, Q, T, R. That's one way. Now, the one thing we have to remember is that when we name an angle, the vertex or the point of the angle is always the middle letter. So I can name it QTR or I could name it RTQ. What I can't do is do something like this, angle QRT. That would be wrong. Or angle RQT. Again, that is wrong because in angle 1, if I'm going to use 3 letters to name it, angle point T has to be the middle value, the middle letter in the name. So looking at angle 2, we have 2 names again. So I can name it angle RTS, or I can name it angle STR. What I could not do is angle RST. That would be wrong because T has to be in the middle. I could also not name it angle SRT. That would be wrong as well. So again, when we name a letter, the vertex, this is called a vertex, has to be the middle letters. Okay, and then we also have a big angle. A big angle, we have angle QTS, and then which is also named angle STQ. So that is angle 1 and angle 2 put together. That would make it angle QTS or angle STQ. So those are some basics in just how to name angles. Continuing on, we're going to now take a look at finding some measures of some angles. So in this picture right here, I have again a large angle. This would be what we call an obtuse angle because it's an angle that's bigger than a right angle. A right angle is a 90-degree angle. So then I'm going to have another ray right here to create 2 angles that make up a larger angle. And I'm going to put some points on here so I can name things. This is point D. This is point E. This is point F. This is point G. And I'm going to tell you that angle DEF has a measure that is 48 degrees, and angle GEF has a measure that is x degrees. And I'm also going to tell you that angle DEG, this big old angle, is 115 degrees. So if we want to talk about the measures of the angles in this picture, we would use a notation that you need to know. If I want to say the measure of an angle, I use this little m in front of the name of the angle. So we'll start with a measure of angle DEF. That is 48 degrees. And then the larger angle, the measure of angle DEG, I could call it GED if I wanted to. That is 115 degrees according to the picture. So if I want to find the measure of angle GEF, we know that's going to be x, but we can figure out what x is. Because according to this picture, x plus 48 is going to equal 115. So I would solve for x by subtracting 48. So 115 minus 48 is 67. So the measure of angle GEF is 67 degrees. Now, there are some words that we might want to use to refer to these angles. So angle DEF is in a fairly small angle measure, and this would be called an acute angle because it is less than 90 degrees. Whereas angle DEG is what we call an obtuse angle because it is greater than 90 degrees. And then again, if we have a right angle, we would mark with a little box. This means 90 degrees. So this is a right angle. That is an angle that measures exactly 90 degrees. All right, continuing on. We'll go to a new picture now, and we have this problem. It says, first of all, we have this drawing. So this is clearly an obtuse angle right here. I'm going to put point R right here, point Q right here, and point T right here. Okay, and then I'm going to put another ray right here, point S. And I'm going to tell you that angle RQS is 4x minus 20 degrees. And this angle right here is 3x plus 14 degrees. And here's the question. It says, if the measure of angle RQT equals 155 degrees, what are the measure of angle RQS and the measure of angle TQS? All right. So before we go any further, we're going to talk about an important theorem that we need to know. And this is called the angle addition postulate. The angle addition postulate says that if you have two angles that are adjacent to one another, then the sum of those two angles equals the larger angle. So from this picture, we would say that the measure of angle RQS, that's this angle right here, plus the measure of angle TQS, that's this angle right here, that would equal the measure of the larger angle, RQT. That is this entire angle right here, which we were told in the problem was 155 degrees. So the angle addition postulate is a lot like the segment addition postulate. So the two parts that make up the whole, you would add the two parts together to make up the whole. So in this problem, we are going to use the angle addition postulate now to solve for x. So RQS is 4x minus 20. TQS is 3x plus 14. And then the larger angle is 155. So now what we're going to do is combine like terms because we have like terms on the left side. We have 4x plus 3x is 7x. Then we have negative 20 and positive 14 is negative 6. Bring down the equals 155. Now we're going to get rid of the minus 6 by adding 6. So 7x equals 161. Then we divide both sides by 7, and we get x equals 23. So now that we know what x equals, we can now use substitution to find out what the measures of each of these angles are. So the measure of angle RQS, from the picture, RQS is 4x minus 20. So that would be 4 times, we know what x equals, so that equals 23. So 4 times 23 minus 20. So 4 times 23 minus 20 is 72 degrees. Okay. And then we need the other angle, the measure of angle TQS. So that expression was 3x plus 14. So that would be 3 times 23 again for x plus 14. So 3 times 23 plus 14 is 83 degrees. So those are our two answers to this particular problem. All right. So now you will have some practice problems to work on for this lesson. And you can use these notes to help you out using the angle addition postulate and equations to solve for a missing variable, plug that value in to find missing angles.